Hey, hi, I am Tanmay Kanapurti with 200447206. So today I'm going to talk about image classifier, and this assignment is quite interesting and I'm excited to do this. This most interesting topic of mine in this entire semester. Let's do this live. So, uh, let me tell you what is an image classifier. Basically, we define a set of target classes and train a model to recognize them. So here we are giving the training data to the machine learning algorithms, and which by assuming it makes a classifier, when you feed the new data to this classifier to test, and it gives out a prediction. This is what we are going to see live next. So for this, let's go into this site. So this is the site where you need to go to do this. And I'm going to create a new project. I'm doing this with bikes. Let's create one. The description motorbikes and create one new resource. Name. Choose cognitive services. This. So you need to create a new resource group over here and give the name. And mine, which I created, is bikes. So let's create a resource. So I've created the resource group. Now I'm going to add a new project here. My Azure credentials have got expired and I'm using my friends. So new project, let me give like motorbikes description. Okay. And see, here I wanted to select multi-label as I'm going to upload multiple images with multiple tags per image. Then I'm going to select this domain as general, and let me create the project. So the project got created. Here we need to give the image tags. So let me go here. So the images to train my model, I'm considering 3 bike manufacturers. One is Ducati, Royal Enfield, and Scooty. So these 3 look in 3 different models but comes under one category, which is bikes. So let me do that. So before I start, I need to tag in this. So let me click on this plus, and mine comes under motorbikes, and it got saved. And my one manufacturer is Ducati, and one more is Royal Enfield. And one more comes under Scooty. So as you can see, there are no images yet in these folders. So now I need to upload the images. So here I have 3 different bikes classified into one, which is motorbikes. So let me add images into this. In mining, let me add Ducati and open. So here let me add my classifier is motorbikes, and this is Ducati. Upload. So all the image reflected here. So you can see here Ducati 7 are reflected over here. So let me add images in the other categories as well. So it's in okay, let's add Scooty. And comes with motorbikes and it's Scooty. Done. Now let's do for the other as well. Royal Enfield is left. Tag with motorbikes, classifier, and so here I added one image more in Scooty. Let's check how it works. So total 7, 7, and 8. So I wanted to train my set. Quick training. Train this. So here my precision recall and AP or 100%. It's perfect. So you can see the image counter here. I've taken one image more for Scooty to test how it works, and remaining both same count. So now we'll go for the quick test. Here I want to browse one of my local files. Let's check this. Yeah, you can see here the Ducati is 0.5% and Royal Enfield is 99.9%, which is perfect, amazingly. Now let's try with the I've saved the test files over here. So it's in, I've already collected the test. So this is one. Scooty, it is coming as 99.6% because the side angle of this is same. Whereas Ducati it is completely 0% because it's like a sports model look, and the category is 90 motorbikes. So now let's check this image. As you can see, this image is like comes into when it is up from the side angle, it's kind of like broad, so the Royal Enfield percent is 12%, but coming to the front angle it is much like the Scooty model, so it is 41.8%. So it's actually a motorbike, 99.6%. Actually it is, but it doesn't know how to categorize it because from the front end it is 41.8%, and the color it has red Scooty in it, so that is why the match is more in this. And coming to Royal Enfield, it is 12% only by this side view, and Ducati is 0. So the same app which I've placed over here, as you can see. And now let's check for the other train. So here when I'm trying to test Ducati, it is 99.9%. Royal Enfield is 0.1% because the side view is different and the color matches 100% in Ducati. So now I wanted to test for Scooty because Scooty the precision level is 100% because I've added one more image. So what I've known from this is what I've learned from this is the more images you add, the more precision it gives, the more prediction is correct. So let me test in the Scooty. So I wanted to add this image. See, the Scooty is 92.9%. because the more images you add, the more accuracy it gets. What I've learned. I don't know how far it is true. So I'm doing this Ducati. It's no chance at all. It's just 0%. So let me just train with one more other. So I wanted to add one image, which is bus. It's just taking time to upload. So I've added this bus image. So here we can see that the Scuti model is 0.6 and Ducati model is 0.1. The Scuti model is high because of the color match which were there in that 7 images, and the Ducati, maybe the side or the side mirror or this angle might be just a 0.1% match, and it's perfect. I'm liking this, that is why I'm going on checking more and more. So I wanted to check which is near to Ducati, which is Karisma, like RN5, and you can see the Ducati is 10.2% and Scuti is 11.8%, which is no match because there is not even this color in my set, and the angle is much more different. Might be it got more because the one more image I have added in this, and might be the side one